of this any thing, it is given to be 21.6 plus minus 0.1 centimeter. So we need to calculate the percentage uncertainty, and it is equal to delta L upon L into 100. Delta L is 0.1 while the L is 21.6 into 100. So percentage uncertainty, it is equal to 0.5%. So next is for the error propagation. Like the length of this rectangle is 21.6 and the error while its measurement, it is plus minus 0.1 in centimeter, and L2, this length is equal to 27.9 and the error in the measurement is 0.1% again, 0.1 again. So the area is L1 into L2. So it is equal to 21.6 into 27.9 is equal to 602.6 centimeter square. Next main problem is the calculation of error in the measurement of area. So this error we can easily calculate from the uncertainty of L1 and L2. So the first step to calculate here is delta L1 upon L1. Delta L1 is 0.1, L1 is 21.6, it is equal to 0.005, and delta L2 upon L2, it is equal to 0.004. Area is L1 plus L2 and its relative error is the sum of a relative error of L1 and a relative error of L2. So delta A upon A is equal to delta L1 upon L1 plus delta L2 upon L2. So this is equal to 0.005 and this is equal to 0.004, and the sum of these two is equal to 0.009. So delta A in the measurement of uncertainty in the measurement of area is equal to A into 0.009. 0.009 into area is equal to 5 centimeter square. So the area is equal to the central value approximate 603 plus minus 5. So this is the error in the measurement of area. From the error we got from the length in the each length L1 and L2. Next are the formula related with the error propagation. These are important formulas. So based upon these formulas we can calculate the total error in the measurement of any formulae. Like if z is the sum of the two values x and y, like we can take a here example v is equal to u plus at. So the total value of z, it is a sum of individual values or it is minus of these two individual value. Then the average deviation, average or absolute error in the measurement of z, it is equal to the absolute error in measurement of x plus absolute error in measurement of y. So here the main point is that if there is plus or minus, the total error is always sum of these two absolute error. It is never in negative, it is always in plus, while the z is x plus y or z is x minus y. So this is simply if we take the average error, delta z is equal to delta x plus delta y. But if we take the standard deviation, then this is equal to delta x square plus delta y square up to so on, and the square root of these sum of all these. So next is the numerical related with this. Here this thing is plus minus. W is equal to 4.52 plus minus 0.02 centimeter. So these are three measurement in W, in X and Y. So we need to calculate the value of Z. Z is equal to X plus Y minus W and its uncertainty. So Z is equal to X plus Y minus W. X is 2, Y is 3 and W is 4.5. So the value of Z is equal to 0.5, while the error, absolute error in the measurement of Z, it is equal to delta X plus delta Y plus delta W. Delta X is 0.2, delta Y is 0.6 and delta W is 0.02. So it gives us 0.82, while this is up to 1 decimal. So this error should also be up to 1 decimal. So it is equal to 0.8 centimeter. So Z total, this is central value, this is error. So 0.5 plus minus 0.8 with average error. So if we take instead of average error, we take standard deviation, then delta Z is equal to 0.633 centimeter. So Z is equal to 0.5 plus minus 0.6 centimeter. So here we need to take care that the central value is up to 1 decimal point. So the error is also up to 1 decimal point to match these two terms, like this up to 1 decimal point, this thing also up to 1 decimal point. This is central value, this is error in the measurement of this value. Next numerical is X. In the measurement of X, the central value is 2 and the error is 0.2, while the measurement of Y, it is equal to 3 plus minus 0.6. So we need to calculate Z is equal to X minus 2y, its central value and its error. So Z is equal to X minus 2y, X is 2, Y is 3, so it is equal to minus 4, and delta Z is equal to delta X plus 2 into delta Y, it is equal to 1.4 centimeter. So with the average error, it is equal to 1.4, but with the standard deviation, it is 0.9. So these two are the values depending upon the average error or standard deviation. Next is another propagation of error. While we are making the measurement of any physical quantity, which is a multiplication of two individual quantities, or it is a division of two quantities, like Z is equal to X into Y or Z is equal to X upon Y. If any physical quantity is the multiplication or the division of two terms, then we can easily calculate the error or uncertainty in the measurement of this quantity Z. So the deviation in Z, it is equal to X plus minus delta X into Y plus minus delta Y, and after multiplying these two, we are getting 4 terms. It is equal to xy plus x delta y plus y delta x plus delta x delta y. Since this is very small, we can neglect this term. So delta z, so we can compare these two terms, like z is equal to xy and delta z is equal to x delta y plus y delta x. Since we are neglecting this term, it is very small. So after dividing this whole term by z, while z is equal to xy, so this is equal to delta z upon z, it is equal to delta x upon x plus delta y upon y. Here the same rule applies, like if we are multiplying two terms or dividing two terms, this sign is always plus. So error is always the addition quantity. It is never subtracted from one value to another. Same rules also apply here. If we are taking average error, then it is simply plus. if we are taking standard deviation, then first we are squaring each measurement and taking the sum of all these value and square root of all these measurement. So this is for the standard deviation. So if these measurement, like this physical quantity x and y, they are correlated with each other, if there is some correlation, then we will take standard deviation, but if there is no correlation, then we will take average error. So this is little if we are taking these two values x and y or any measurement, if they are correlated with each other, then we will take standard deviation. If they are not correlated with each other, then we will simply take average error. Next numerical is related with the multiplication. W is 4.52 plus minus 0.02 centimeter. X is 2 plus minus 0.2 centimeter. So the measurement in Z is equal to W into X, and we need to calculate its uncertainty. So Z is equal to W into X. W is 4.52, X is 2, so the value is 9.04, and the average error is delta Z upon Z is equal to delta X upon X plus delta Y upon Y. Here instead of X we are getting here W and X. So delta Z upon Z 9.04 is equal to 0.02 divided by 4.52 plus 0.2 divided by 2 is equal to 0.1044. So the average error is 1.1044 into 9.04, it is equal to 0.944, and round to the one digit, it is 0.9. So the value is 9 plus minus 0.9. Here one thing to be noted that this value is up to 1 decimal. This is because the least precise of these two. So the precision here is 1 decimal, here it is 2 decimal. So the final answer is least precise. So the least precise is 1 decimal. So the answer should be in 1 decimal. So Z is equal to 9 plus minus 0.9. If we take standard deviation instead of average error, it is equal to 0.905. So Z is equal to 9 plus minus 0.9. Next numerical is related with the division of these two quantities. X is equal to 2 plus minus 0.2, y is 3 plus minus 0.6. So the physical quantity Z, it is related with x and y, with Z is equal to x upon y. X is equal to 2 and y central value is 3. So Z is equal to 0.6667 centimeter per second. Here it is also up to 1 decimal. So average error, it is equal to delta Z upon Z is equal to delta Z is equal to 0.3 into 0.6667, it is equal to 0.2 with the average error. But if we take the standard deviation instead of the average error, then it is equal to 0.15. So with the standard deviation, it is equal to 0.67 plus minus 0.15. But if we want to check the round of answer, then it is also equal to 0.7 plus minus 0.2 centimeter per second. Next final is the product of power. If we are getting like this, Z is equal to x m y n. So the simple, if we take the simple average error, then delta Z upon Z is equal to m delta x upon x plus n delta y upon y. But with the standard deviation, it is equal to delta Z upon Z is square root of m delta x upon x square plus n delta y upon y square up to so on. This is one numerical related with these formulas, like Z is equal to wy square divided by a half. So we need to calculate the delta Z. So we know delta z upon z, it is equal to delta w upon w plus 2 into delta y upon y plus half into delta a upon a. So after calculating all these things, we are getting with average error it is equal to 29 plus minus 14, but with the standard deviation it is equal to 29 plus minus 12. Thank you.